Pick up a rock. Seriously, any rock. Now look at it for a second, because hidden inside that ordinary piece of stone is everything you need to build a computer. Not metaphorically, literally. The same silicon locked inside rocks and sand is the foundation of every smartphone, laptop, gaming PC, and supercomputer ever built. But here's the real question. If civilization disappeared tomorrow, no factories, no electricity, no tools, no internet, nothing, and all you had was a single rock, could you ever build a computer again? At first, it sounds impossible. But the real surprise isn't that it's possible. It's discovering just how many impossible problems humanity had to solve before a computer could ever exist. So let's start at the very beginning. At first, this almost feels too easy. You have a rock. Computers are made from silicon. Silicon comes from rock. So, problem solved, right? Not even close. The silicon trapped inside that rock is mixed with oxygen, iron, aluminum, and dozens of other elements that make it completely useless for building a computer. It's like trying to build a Formula One car out of rusty scrap metal. So your first challenge isn't building a computer, it's separating one element from everything else. To do that, you'd need temperatures close to 2000 degrees Celsius, hot enough to melt rock itself. Finally, you've got silicon. Except it's still not pure enough. The silicon you've made is about 97% pure, until you discover that modern computer chips require 99.9999999% purity, 11 nines, 1 microscopic impurity, 1 invisible grain of dust. That's enough to stop an entire processor from working. The difference between an ordinary rock and the processor inside your laptop isn't intelligence, it's purity. Suddenly, building a computer doesn't feel like an engineering problem anymore. It feels like a battle against chemistry itself. And here's the crazy part. You still haven't built a single piece of the computer. You've only earned the chance to begin. Let's say you've done it. Against all odds, you've created silicon pure enough to build a computer. It's not. You've actually built nothing. Because pure silicon can't think. It can't calculate. It can't even remember a single bit of information. Before it can become the brain of a computer, every atom inside it has to line up in almost perfect order. Nature almost never creates crystals this perfect. First, the silicon is melted into a glowing liquid at over 1,400 degrees Celsius. Then something almost unbelievable happens. A tiny crystal is lowered into the molten silicon and slowly lifted upward. So slowly, you could barely see it moving. As it rises, billions upon billions of atoms begin arranging themselves into the exact same pattern, one layer at a time. It's less like manufacturing and more like growing an artificial crystal from liquid rock. If the temperature changes, even slightly, if the crystal vibrates, even once, weeks of work can disappear instantly. Imagine stacking billions of invisible Lego bricks without making a single mistake. That's the level of precision required before you've built even one part of a computer. When it's finally finished, you have something extraordinary. A silicon crystal so perfect, it could one day become the brain of the device you're watching this video on. But even now, it still can't perform a single calculation. The hardest part is still ahead. Now you have something extraordinary, a crystal so pure, it could one day become the brain of a computer. There's just one problem. It still isn't one. Right now, this flawless crystal is no smarter than the rock you picked up at the beginning of this video. It can't remember, it can't calculate, it can't even tell the difference between a 1 and a 0. So how do you teach a rock to think? Surprisingly, you don't. You teach it when to let electricity pass and when to stop it. That's it. That's the secret behind every computer ever built. Silicon has a remarkable property. It's neither a perfect conductor like copper, nor a complete insulator like glass. It exists somewhere in between. And that tiny in-between is what changed human history. By adding unbelievably small amounts of elements like phosphorus or boron, scientists can change the way electricity moves through the crystal. Suddenly, your rock has learned its first decision, on or off, 1 or 0. It doesn't sound impressive. One switch can't run a game. One switch can't even display a single pixel. But billions of these tiny decisions, made billions of times every second, allow your computer to write essays, edit videos, land spacecraft, and even run the AI you're listening to right now. Every message you've ever sent, every YouTube video you've ever watched started with this one simple choice: on or off. But teaching a rock to make decisions creates an even bigger challenge. How do you fit billions of those tiny switches onto something smaller than your fingernail? You've done the impossible. You've purified the silicon. You've taught it how to make decisions: on or off, 1 or 0. But there's one final problem. One transistor isn't a computer. Neither are 1,000. Modern processors contain billions. So how do you place billions of microscopic switches onto a single piece of silicon without making a mistake? You don't build them. You print them with light. But that's exactly what happens. The silicon is coated with a light-sensitive material called photoresist. Then an incredibly precise machine shines ultraviolet light through a microscopic pattern, almost like projecting a tiny stencil. Where the light touches, the surface changes. Where it doesn't, nothing happens. Now chemicals wash away only the exposed areas, revealing patterns far too small for the human eye to see. Then the process repeats, again and again, more than 100 times. Each new layer adds another tiny piece of the puzzle, until billions of transistors slowly emerge, not one by one, but all at once. And here's the part that feels almost unbelievable. The switches inside your processor are measured in nanometers. A human hair is about 80,000 nanometers wide. That means thousands of transistors could fit across a single strand of your hair. At that scale, dust becomes the enemy. One microscopic particle, too small to notice, can destroy an entire processor before it's even finished. That's why these chips aren't built in ordinary factories. They're built inside clean rooms, so spotless. They're cleaner than most hospital operating rooms, because at this point, you're no longer fighting against nature. You're fighting against imperfection itself. And after all of that, after the heat, the chemistry, the crystal, the light, you still don't have a computer. You've only built its brain. At last, you've built the brain, a tiny silicon chip capable of making billions of decisions every second. But there's one problem. A brain alone can't do anything. It can't see. It can't hear. It can't store memories. It can't even turn on. To build a real computer, your journey is no longer about one rock. It's about the entire Earth. Now you need copper to carry electricity, gold to protect delicate connections from corrosion, lithium to store energy, glass for the display. Suddenly, your computer isn't one invention anymore. It's a collection of mountains, transformed into technology. Every material tells a different story, a different mind, a different breakthrough. Thousands of years of human curiosity compressed into a machine that fits on your desk. Think about that. Your laptop isn't just a computer, it's chemistry, physics, engineering, and millions of people across thousands of years solving one impossible problem after another. But even after gathering all of those materials, after building every single component, your computer is still missing something, because no matter how advanced the hardware becomes, it's completely useless until everything learns to work together. At this point, you might be wondering something. Has anyone actually done this? Has anyone ever started from almost nothing and built a computer? Surprisingly, yes. Not a modern laptop, but something just as important. Engineers have built fully programmable computers using nothing more than individual transistors wired together by hand. They're enormous, painfully slow. A computer that fits in your pocket today is millions of times more powerful. But that's not the point. They proved something extraordinary. A computer isn't magic. It isn't one miraculous invention. It's simply billions of tiny decisions working together, one after another. Even more fascinating, artists and researchers have experimented with raw quartz crystals taken directly from nature, exploring whether the electrical properties hidden inside ordinary minerals could perform simple forms of computation. Not because anyone expected to replace modern computers, but because they wanted to answer a deeper question: how much of a computer already exists inside the natural world? The answer is astonishing. far more than you'd expect, but nowhere near enough, because no matter how smart the material is, without thousands of years of accumulated knowledge, it's still just a rock. So, could you build a computer starting with only a rock? Maybe, but not by yourself, because the rock was never the hard part. The hard part was building the civilization capable of understanding it. Thousands of years, millions of failed experiments, countless people, most of whose names we'll never know, each solving one small problem after another. How to make fire, how to shape metal, how to make glass, how to control electricity, how to understand atoms. Until one day, a simple piece of stone became something capable of processing billions of calculations every second. The next time you pick up your phone, open your laptop, or ask an AI a question, remember what you're really holding. You're not holding metal. You're not holding glass. You're holding thousands of years of human curiosity, compressed into a machine that fits in your hands. Every message you've ever sent, every video you've ever watched, all of it started with an ordinary rock. And maybe that's the most incredible part of all. The computer was never the miracle. Human civilization was.